Okay, so for this last section on mass versus the state of matter, you are going to want a periodic table to look up masses, and you are going to want a calculator. So what we are going to do is we are going to look at the mass of these different substances and their type of intermolecular force, and then I've given you what their normal state of matter is. Okay? So we have Cl2, a chlorine molecule bonded to itself. Okay, or excuse me, a chlorine atom bonded to itself. All right. So we would expect that to be nonpolar covalent because we know that they're going to share the exact same electronegativity. So if that is nonpolar covalent, the only type of intermolecular force present here should be a London dispersion force. And you'll notice that at room temperature, chlorine is a gas. So let's go ahead and find chlorine's mass. We're going to get the mass off the periodic table, which for chlorine is 35.453. And we're going to add another 35.453 to that. So the mass of chlorine is 70.906. So you would record that value there. Now, bromine, on the other hand, Br2, again, an atom of bromine bonded to an atom of itself. We know that the electronegativity difference there is going to be 0, so this is going to have to be a nonpolar covalent. So again, the only type of force holding this together is a London dispersion force. So the same force that we have with chlorine. But bromine is a liquid at room temperature. So let's see if we can figure out why that is. Bromine has a mass of 79.904. And we're going to add 79.904 since there's two of them. So that's a total mass of 159.808. So you'll notice that these two had the exact same intermolecular forces, but because the mass is greater, we're in the liquid phase instead of the gas phase. Okay, so what's holding us in the liquid phase? Well, it's not the London dispersion forces because that wasn't enough to hold the chlorine in the liquid phase. So it must be the mass. Okay? Remember that in order for something to evaporate, it has to have enough energy for it to escape the liquid. Okay? In other words, the particles have to have enough energy to move away from one another. Okay? And the attractive forces that are holding them to each other, these intermolecular forces, are incredibly important in that, but also is their mass. Okay? A bigger compound is going to take more force or more energy to move. Okay? So we have two things at play here to determine the state of matter that something's going to be at room temperature. Number one, their intermolecular forces, but also their mass, because they can have the exact same intermolecular force and not be in the same state of matter because of their mass. All right, so I'm going to have you guys do the rest of these, where you're going to calculate the mass for these, determine their type of intermolecular force, and look at their state of matter and see if you draw any other conclusions about the intermolecular forces versus the mass, and whether sometimes it's the intermolecular force being different that matters rather than the mass being different.